Hi, I'm Todd Spatafor, and this is another spectacular thing. Last time we created a Raspberry Pi 4 Kubernetes cluster, and we set up a pod with nginx running in it. But there's a problem with this setup, and I'm going to show you what it is. We've got our pod nginx deployment. Now let's go ahead and create a custom index page for that pod. If I can spell correctly. Now if we look at the website, we can see my custom page appears. Now it's looking good. Now watch this. Okay, so we've deleted the pod, and you can see another one spun up. See the name is different in this pod than the last one, and it's been running for only 12 seconds. Now if we look at that web page, we get 403 forbidden. It's gone. Everything in our cluster is ephemeral right now, and today we're going to fix that with persistent storage. We're connecting our cluster to this Raspberry Pi 5 NAS using NFS for network storage. When we're done, our nginx data will survive pod deletion, node failures, and even cluster restarts. So what's in this video? Here's our plan. First, we're going to understand persistent volumes and persistent volume claims. Then we're going to create our first persistent volume. We're going to update nginx to use it, and then we're going to prove that the data survives. Let's go. Kubernetes pods are designed to be ephemeral. They come and go. That's perfect for stateless apps such as web servers or API gateways. But what about user content, databases, and configuration files? Well, those need to persist. That's where persistent volumes come in. There's two concepts that we need to address here. Persistent volumes is the actual storage. Think of it like a hard drive. It exists. It has capacity. It lives somewhere. In our case, on the NFS server. Persistent volume claim is a request for storage. A developer says, I need 1 gigabyte of storage. Kubernetes finds a persistent volume that matches and binds them together. Once bound, the pod can mount the PVC, or persistent volume claim, and use it like any other volume. But unlike container storage, this volume persists outside the pod. So why separate them? Well, separation of concerns. You see, cluster admins create persistent volumes, and developers create persistent volume claims. The developer doesn't need to know anything about NFS or the IP address of the server or the mount point on the server. They just create a persistent volume claim to request the storage from the PV. Okay, enough theory, let's build it. Quick note, I already have NFS running on my Raspberry Pi 5 NAS from a previous video, link in the description. Let's go ahead and check this out. You can see here that I have two exports, one for MNT RAID share and one for MNT RAID Kubernetes. This exports both of these to my home lab network on 10.51.50.0 with a network mask of 23. The all squash maps all users to user ID 2000. This avoids permission headaches. Let's verify it's reachable. And you can see both of them are reachable from my current machine. Now let's create the storage. Let's look at our persistent volume YAML. Let's walk through this. First thing we see in our spec is a storage capacity of 10 gigabytes. This persistent volume provides 10 gigabytes of storage. Its access mode is read-write many, and what that means is multiple pods can mount this at the same time for read-write access. It's perfect for nginx serving static files. Next is the NFS server IP address and the path on that server of the NFS share. And finally, we have the persistent volume reclaim policy, which is set to retain. When the PVC is deleted, we want to keep the data. We can manually clean it up later. Notice we're hard-coding the NFS details here. That's fine for now, but later in this series we will automate this with dynamic provisioning. Now that we've created the YAML, let's go ahead and apply it. And it's created. Now let's check the status of it. We have an NFS persistent volume, capacity of 10 gigabytes, read-write many, access mode. The retained policy is the reclaim policy is retained. The status is available. That means it's ready to be claimed. This is the persistent volume claim. What this is requesting is, it says, I need 10 gigabytes of read-write many storage. No NFS server, no paths, just requirements. Kubernetes will then find a persistent volume that matches and binds them. Let's go ahead and apply this. And you can see that it's been created. And let's check it. The status is bound. It found our persistent volume and claimed it. Let's check the persistent volume again. And you can see the PV is now bound too. Next, let's update the nginx deployment. In our deployment that we have for this video, we have a volume mount, name HTML, mount path is user share nginx HTML. That's so that we can actually make a change to the index file. And you can see the volume name is HTML of an empty directory. That allowed us to create our custom index.html file that was ephemeral. When we killed the pod, that directory got spun up again with an empty directory. So let's go ahead and change this with our persistent volume claim. And our claim name is NFS PVC. So as the developer, I don't need to know the path on the NFS server of the persistent volume. All I need is my claim name of NFS PVC. So nginx will serve files from the NFS volume instead of its ephemeral file system. Let's go ahead and apply. And you can see that our new pod is running. Its age is 5 seconds. Now it's using the persistent volume. Let's test it. Let's go ahead and create some custom content. First, we'll execute interactively into our pod so that we can echo, or we can create our custom index page. And here you can see the index page that we are going to present to the user. Let's go ahead and view this page. And you can see our persistent storage page comes up. Now what happens when we delete the pod? Let's go ahead and do that. And you can see a new one spun up in 6 seconds. Now what happens when we view the same page? Our persistent storage kept the index.html file. It's still there. Our custom page survived. Let's verify this on the NAS. And there's our index page, sitting on the NAS. But pods come and go, but the storage remains the same. Let's recap. We created a persistent volume that pointed at our NFS share. We created a persistent volume claim that requested that storage. Then we updated nginx to mount that PVC. Then we proved that our storage was retained after a pod deletion. We now have persistent storage in our cluster. So what's next? Right now we're manually creating persistent volumes. That works, but it isn't scalable. Later in this series, we'll set up dynamic provisioning so storage gets created automatically upon request. But now we have what we need to deploy a real service. In our next video, we're going to deploy Git, a self-hosted Git server. We'll use persistent storage for the repositories, and we'll introduce stateful sets for the database and start building out our cluster. Thank you for watching. If this helped, please drop a like, subscribe if you're not already, and if you've got questions, especially about storage, leave them in a comment below. Thank you for watching, Have a great day. Bye.